Our Cisco Catalyst switches support a couple of different protocols that can do link aggregation. One is a Cisco proprietary protocol, and that protocol is called PAGP. Port Aggregation Protocol is what that stands for. And we also have LACP, the Link Aggregation Control Protocol. That's part of the industry standard approach to logically creating a port channel. That's part of the IEEE 802.3 AD specification. And when we interconnect a couple of switches using multiple links, let's think about how an ether channel gets negotiated. Let's take a look at this for PAGP as well as for LACP. First of all, we need to make sure that all the ports are set up identically. They should have the same speed. They should have the same duplex. They should have the same VLAN assignments. But assuming they're matched up, we can put these ports into a specific PAGP channel mode. We can select either on, auto, or desirable. On means that we're not going to be sending out PAGP frames, we're just telling these ports to be a channel. And if we have both sides set to on, as we're trying to form a channel will be formed. So on both sides will form a channel. What if one side is set to on and the other side is set to auto? Well, auto is not going to be sending PAGP frames. It's willing to respond to PAGP frames. If it receives one, if it sees that the other side is suggesting that a channel be formed, a port set to auto will form a channel. However, we said that on was not sending PAGP frames. And as a result, if one side is on and the other side is auto, we will not be forming a channel. What if one side is on and the other side is desirable? Here's what desirable does. Desirable is willing to become a channel if it receives a PAGP frame from the other side, and it's even willing to initiate the conversation. It will send PAGP frames asking the other side to form a channel. However, if one side is set to on and the other side is set to desirable, the desirable side will never see a PAGP frame because the on side is not going to send it, so a channel is not going to be formed. And we've already said if one side is set to auto and the other side is set to on, no, we're not going to have a channel form. What if both sides, though, are set to auto? Well, in this case, each side is willing to become an ether channel. However, nobody's initiating it. Neither side is sending out PAGP frames, and as a result, no channel gets formed. What if one side is auto and the other side is desirable? In this case, yes, we will have a channel form because the desirable side will send PAGP frames, the auto side will see that, and when it sees that, it will talk with the other side and a channel will be formed. We've already said that a combination of desirable and on will not form a channel. We've already said that desirable and auto will form a channel. The final combination is desirable and desirable. Here, both sides of the conversation are sending PAGP frames, and both sides are willing to negotiate a channel, so yes, an ether channel will be formed here. This is very similar to how LACP works. The modes are slightly different. We have on and passive and active. Passive is a lot like the auto mode for PAGP, and active is a lot like the desirable mode for PAGP. And on is similar to the on mode for PAGP. If both sides are set to on, yes, a channel will be formed because we're just telling both sides to be a channel. They're not negotiating with LACP frames at all. If one side is on and the other side is passive, no, we will not have a channel because the passive side, in order to become a channel, it needs to receive LACP frames, and it's not going to be receiving those because the on side will not be sending them. The active side will send LACP frames. However, the on side will not respond to those, and as a result, we will not have a channel formed if one side is on and one side is active. If one side is passive and the other side is on, we've already said no, that will not form a channel. If both sides are passive, this is similar to having auto with PAGP. Nobody's sending LACP frames, and as a result, no channel is formed. If one side is active and the other side is passive, then yes, a channel will be formed because the active side is actively sending LACP frames. The passive side will respond to those, and a channel will be negotiated. We've already said that a combination of active and on will not work. A combination of active and passive will work. The final combination is active-active. Both sides are sending LACP frames. They're both willing to participate in a channel negotiation. So yes, a channel will be formed if both sides are set to active. Let's take a look at how to configure an ether channel between switches A and B. We've got a couple of links. and we want to bond those together. And we're going to use the Cisco approach to Ether channel, where we're using PAG-P instead of the industry standard, which uses LACP. And remember the prerequisites. We need to have the speed and the duplex identical on both switches. They need to be assigned to the same VLAN, or if they're a trunk, they need to allow the same set of VLANs. I've not modified any of that. However, I am interconnecting these switches with straight-through cables, so I'll want to use MDIX to automatically negotiate which pins are receive and which pins are transmit. So let's go into interface range configuration mode on switch A. I'll say interface range for fast Ethernet 1/0/1 space 2, and I'll say speed auto, because in order to set up MDIX, speed and duplex have to be set to auto. Speed auto, duplex auto, MDIX auto. Now let's set up our channel group. I'll say channel-group 1 mode, and context sensitive help reveals our different options that we've talked about. Let's set this up for desirable. That's going to be using PAG-P, and desirable will send PAG-P frames in addition to respond to any PAG-P frames it receives. We'll set this side to desirable, and it says it's creating an interface, a virtual port channel interface, which means I can go into interface configuration mode for that port channel. Let's go into interface port-channel 1. And I want to configure this port channel interface as a trunk. After all, we're bundling these links together. What better place to have a trunk than where we have extra bandwidth to carry traffic for multiple VLANs? I want to make sure that I'm using the .1Q trunk encapsulation type. We'll say switch port trunk encapsulation .1Q. And I'm just going to force this to be a trunk. I'll say switch port mode trunk. And I'm done on switch A. Let's move over to switch B. Let's set up an Ether channel here as well. Let's go into interface range configuration mode for gigabit 0/9 through 10. And I'll set the speed to auto on this side and the duplex to auto on this side as well. And let's create a port channel interface. Let's say channel-group 1 mode. And I could say auto, or I could say desirable. Either one would work. Just to prove that point, let's say auto on this side. And let's go into interface port channel 1 configuration mode. And let's set up a trunk. Let's say switch port trunk encapsulation .1Q. And let's set the mode to be a trunk. We'll say switch port mode trunk, and we're done. Let's verify that our newly created port channel interface is up and operational. Let's do a show IP interface brief, and we'll see a brand new interface. Here it is, port channel 1, and it is in the up state. Fantastic. We can even see that it's a trunk. If I do a show interfaces trunk, we can see that, yes indeed, PO1, that's our port channel interface, it is a trunk. That's a basic demonstration of Ether channel where we have logically bundled together a couple of physical links. This can give us some load balancing, this can give us higher throughput, and this can give us redundancy.